Hi everyone, welcome to fifth edition of our LinkedIn Gen AI series. It's a exciting world out there. A lot of new things coming out every day, every week. So it's never enough to learn and know what's going on around. But then I think we should do our bit, and I'm doing my bit to help you understand what's going on. And in the process, I'm also learning a lot. So this week, we are focusing on VectorDB in the context of generative AI. And but then before that, I'll do a quick recap of what we discussed last time, and then we'll jump right to the topic. I will quickly show you what you got. So basically, that's me. And this is, like I said, VectorDB, and it's chapter 5. So last week we spoke about, hey, there are four giant Gen AI companies, like, on board. One is OpenAI, we got Azure, we're talking about AWS and Google. Each of them have their LLM, which is generative AI models. For example, AWS came back with something called Bedrock, and it's actually a container. It can they have a native LLM called Titan, but then you can also integrate things like Anthropic or any of their open source or commercial LLM so that they support. So it's not just one a large language model. They have their one native one, which is Titan, but then there are also other things that you can integrate. As opposed to what Azure does, Microsoft, it only integrates with the OpenAI LLMs. Since OpenAI is good enough, like it's generic enough and it's a comprehensive enough, they're, I think, doing a very good job able to lead this pack. But then as we go in the future, we will see, what will Microsoft do? Will they allow more, outside LLMs, or will they continue to scale what they have? And Google seems to be following what Amazon is doing, or the vice versa. Is Google also support, some of the open source LLMs, and that's how they are growing their stack. We spoke about Code Assist, which is a codex in multiple different LLMs, and that's going well as well. Top ones being Code Whisperer from Amazon. We have a GitHub Copilot from Azure, and so on and so forth. So we spoke about open source LLMs like Hugging Face, Alpaca, the stability AI and stuff like that. Some of them are open source, some of them are not. So that was the landscape when we spoke last time. Let's quickly catch up what's going on now. Jump into today. There is a company called Reka, REKA, .ai. This was in a stealth mode all along, and suddenly it actually came out of the stealth mode with $58 million of funding. And that just blows my mind because it's these companies are just getting started. But if you look at their valuation and funding, and it just mind blowing. The best part is the founders of these companies are have managed significant portfolios in DeepMind, and Meta, Google, Vertex, and also some other folks in Microsoft. These are all like PhD scientists who worked on these large language models, were actually the brain of major releases of LLMs. Now they all got together to actually create their own, and looks like this is something to watch out for. That's Reka.ai. AI. And think about it. So Databricks purchased Mosaic ML for $1.3 billion. Think about this. This company has about 60, 65 employees. It's been around about 1.5 years, around that time. And the company is actually valued at $1.3 billion. So I think we are just beginning in this AI world, in terms of what are the possibilities. And it took maybe a century ago, 5 decades ago, it took a company from going from a small company to a billion-dollar company, probably took them decades. Now we are talking about years. Maybe in the future we are talking about months as well, right? So now, with that, let's jump into today's topic, and see like what are we actually getting into. So we're going to talk about vector DBs. So these are very interesting traditional non-traditional databases, and they are going to have a significant impact on how we are going to use generative AI. But before I jump in there, I'm going to talk about top 5 vector database companies in the world right now, in the market, and what are they doing. So I'll start with that to kind of spice up this discussion a little bit. So we're talking about Chroma. Most of the people are then we're looking at Viviate, Milvus, Quadrant, and then Pinecone. There are many other ones in the market, but I think these five, I think we keep hearing about them, and some of them are open source, some of them are not, but these are the top ones. But think about, look at this one now. Viviet raises, $50 million in a Series B. Okay. And Milvus, the vector database actually raises $60 million. Quadrant raises $7.5 million in a seed funding. It's a baby small company. And Chroma raises $18 million. And we are talking about Pinecone is valued at $750 million with $100 million is the most recent funding. So all in all, they've got about 136, 138. I think if I remember correctly, that's the total funding they have got so far. So this is what is going on for vector databases alone. I'm not talking about generative AI. I'm not talking about any other traditional AI companies. These are just simple vector database companies. Okay, that's exciting. So now let's jump into what is vector database. So let's talk about what is a database. So in the traditional world, you want to store a structured data, and you have the format of tables, and so you basically store that data there. It makes it easy for your applications to retrieve whenever you need, based on the depending on the type of database. DB may such a document DB, or it's a key spaces, depending upon what you store there. You basically have an index created, and you fetch for that particular data, and based on certain the index parameter, or a particular record, and you'll be able to actually pull out the entire data. Right? This is true for structured data. But what happens if it is unstructured data? So imagine you have to store an index, images, and then video files and audio files and text all together in one single database. How will that work? So if you look at how Google search works, or Bing, essentially they are indexing unstructured data, to the most part. And when we do that, what we basically do is we kind of assign key value, the tags to them to describe that particular object. If it's a dog image, you basically say it's a dog, puppy, and all other terms that comes with it, and then you basically have all those tags. And these tags are kind of stored in a database, and these tags kind of refer to these images or videos, depending upon. So most of the times these tags are created manually, or you crawl through some kind of automated tooling, but it's a very cumbersome process. But that's what we knew before. That's what we did. So coming to vector databases, so to solve this problem of this complexity, and most of the times the accuracy kind of suffers. When you actually do an image search with a Google or Bing, most of the times you don't get what you want, just because it's not a scientific way of reading or going through what is the content. It is just the tags. So if the tags are good, you results are good. If tags are not good, then you're basically not going to get what you want. So what does VectorDB do? So VectorDB basically looks at an unstructured data, and it could use deep learning models, or it could use a traditional ML, but it kind of converts the coordinates of that unstructured data into something called embeddings. So what is vector? Vector is nothing but it's an array of numbers, right? And each image or each video or audio, whatever object you are trying to store, will have a vector created for it. But then the way the vectors are created is based on the similarity, right? So all the images will have certain model to get them to certain kind of similarity, which means that when you compare two objects, so if the vector, the difference is actually minimal, the lower means they are most similar kind of thing. So to put these things into perspective, now you look at it, right? You have images, you have text, and you have audio. Each one is going through their codecs. Like, for example, image is going through image transformer, but then it gets transformed into a vector. Text is going through the NLP, natural language processor transformer, and then audio is going through audio transformation transformer, and then all of them but get converted to same vector, which is an array of numbers. Now, this vector gets converted into finally, all these they're called vector embeddings, right? Each object will have a vector embedding, and they're now stored in a vector database. So vector database can have multiple dimensions depending upon. So you could visualize up to 3 dimensions as a human being, but you could go up to a number of different dimensions, and machine can understand it. So look at this image. This image basically talks about 3-dimensional situation where one side of it, you have a chicken, wolf, dog, cat. So this dimension is all about animals, right? And and then if you saw other side, if you see all these dimensions basically have banana, apple. So you have all fruits together group. But if you go a little left of the apple, you also see Apple company. Okay. So that is a similarity between those two. Just the name is a similar, nothing else is similar to them. That's why apple and banana are grouped in one, the same pane, but one side of it, on the other side, you see Apple and Google are there. So when there is a query for kitten comes in, basically it comes to the domain or the group of the vectors that are stored near the cat or animals, right? So this is a very simplistic, oversimplified diagram of 3D, but then it could go to many dimensions depending upon your compute power that you have and then how you design it. And you could store, the large amount of unstructured data and happily retrieve it based on the likelihood of all the similarities and everything. And this will have much more accuracy as compared to traditional databases. Okay. Now that we know what vectors are nothing but it's array of numbers, and we know what are the vector embeddings. Vector embeddings are nothing but every object that you're looking to store in a database are assigned to vector embeddings, and that vector embedding is actually stored in a vector database. As simple as that. Now let's see what are the basic advantages of this and real-time use cases, right? So when you look at it, one is, so while we spoke about vector databases, we said, hey, this can actually help store and retrieve unstructured data. But then let's look at it in the LLM generative AI world. In generative AI world, without vector database, every time you do a query, a prompt to LLM, that prompt has to go from your machine or your environment to wherever the LLM is, like could be Microsoft, Google. Each time you are sending a payload and getting the response back, you are actually paying for that the traffic, depending upon number of tokens, and also your experience that latency, right? And if your organization has 100 employees and 100 of them are probably doing a similar searches, if there is a 50% similarity, it does not matter because you're not doing any kind of local caching. Everything has to go and come back, and that's very inefficient. So to help with that, vector database actually can sit in between your prompt engineering engine on the user side and your LLM. So it can actually serve as a long-term memory for LLMs, which means that most of the similar searches will be written from a vector database, and it does not actually get forwarded to the LLM, saving you time and money in both cases. And since it's actually powered by generative AI or some kind of a large language model, it is like pretty close, accurate as compared to or similar to when you actually send the traffic all the way back to LLM. So it can be used for semantic search, search based on a meaning or a context. It's not like generally you can actually use NLP to query it. So since it is stored based on the similarity, you are most likely to get a result which is close, or you can actually improve your prompt to actually get exactly what you wanted in one or two iterations. So similarity search, like I said, images, text, whatever, depending on like basically you're looking for a dog called Jimmy, and you first look for dogs, and then like filter them for Jimmy. So you can actually more and more refine the search depending upon what you want. You can use this for recommendation engines. For example, customers are doing some kind of shopping. Generally, we try to read their data and try to see their shopping ability, the habits. But with this now with VectorDB, when they're shopping for certain type of items, then you'll be able to actually go to the database and see see like all the similar items and be actually recommend, and it's most likely to actually gain their confidence and probably they'll buy it, because it feels more natural to them that, hey, I think this makes sense, this particular recommendation. It improves, like I said, round trips and performance, obviously, because every query is not going to all the way, to the other side of the planet to hit your LLM. Sometimes it probably, even written from your part of the cloud, and that makes it easy for you. And then if it is in the same VNet and same network, it kind of, helps you save time, especially your volume is high. And last but not least, it actually reduces the cost because depending upon type of LLM you use, your cloud bill could run into thousands and thousands of dollars, and you could actually save using VectorDB, right? So that's the exciting stuff about VectorDB. Like, we spoke about different companies, we spoke about what it does, we spoke about what are the benefits, and I really hope this helps you, and you'll go do a little more research. And there is the 5 companies I spoke about. Go and do some more research. Apart from these 5 companies, you could implement VectorDB using Redis. It's a commercial DB. Redis is pretty cool. You could implement it using OpenSearch. OpenSearch uses under the similar concept. You could implement this using ClickHouse. Okay, some of the LLMs, some of the VectorDBs I spoke actually use ClickHouse under the hood. So most of these, the databases I spoke kind of, under the hood use the vector format. So you could experiment with one of them and see what works for your company. So with that, I think we are towards the end of this session for the generative LLM, and you might be wondering what next. So in the next session, we are going to talk about LangChain, and it's pretty fascinating. LangChain takes your battle for AIs to the next level. It kind of helps you harness multiple large language models into one, and it'll make it look like a single model for your end users, and that's super fascinating. So I'm going to talk about some real-time practical examples and how it works, and I'll see if we can actually show you some demos next time. And then I'll also come with some more news. Until then, keep exploring and keep learning on generative AI, and take your business and your career to the next level. See you in the next video.